Now, what is an echo? Echo happens, like I said, because reflection of sound. Now, how does it happen exactly? We'll explore that, all right? Think about it this way. I happen to shout, or you happen to shout, that wave happens to translate through the air, which is the medium, go and hit an object, and that object kind of sends it back in its same direction, and it comes and hits our ears. So the sound that I produce with my vocal cord is actually going there, hitting something and coming back. Since it has to travel, what's traveling? Not the particles, but the wave of sound, which travels and comes back. Obviously does it with a particular speed because the medium is here. And there is a distance that it has to travel because of which it takes some time. Which is why it feels as though when we hear it back again, we hear it as a distinct sound. Now, what exactly is happening here? Bouncing off of sound is what is happening here. Sound goes, hits something and comes back and we can hear it, right? So I say, hey, it goes and I hear a hey, hey, hey. You see, that's how exactly this is behaving. Now, I can think of it as, why does reflection happen at all? But that's a very tricky thing to answer. In fact, reflection of sound kind of happens with every object, most objects as is. Reflection is not the only thing that happens. Absorption is another thing that happens. Now, what is absorption? We'll have an intuitive understanding of that, right? Where sound energy is absorbed. After all, it's a mechanical wave. That means particles are moving. If I can somehow convert that motion into something else, the wave will now stop behaving like a sound wave. There are ways to do that. And then there is transmission. What is transmission? You have also heard of this when I spoke about light. Transmission is basically when something just lets sound pass through. So either sound, the person or the wave who's traveling, can be blocked, or his energy can be absorbed, or it can be blocked and asked to go back the same way, reflected, or it can be just allowed to pass through, transmitted. Now here's a quick understanding. Now, there. Now, if there is a source that's giving out sound, remember this, sound is given out in all directions. It's not unidirectional. But that's a little confusing for us to look at those waves. So let's shift yes. So you see those lines, right? That's the direction in which sound is moving. If I were to look at a closed group of lines, see, they come, they hit the surface, and then they go and reflect back into the ear. That is the cleanest way in which you can understand sound. And the best part, you've learned this about light already. This also follows the laws of reflection. You remember when we studied about light and the laws of reflection? We did not say laws of reflection of light. This works to be true as laws of how things would reflect, things or phenomena. Now in this case, again, remember that the incident sound that we're looking at and the reflected sound that we're looking at happen to be on the same plane, and the angle of incidence is equal to angle of reflection. And wherever our ear is, that's the region of sound that's coming to us from all the sound that's given out. Which is why as we move further away, lesser and lesser comes in. That said, why is it that echoes happen when we're going on our holidays, but standing in a normal room, we don't hear echoes as much? Well, indoors, does echo happen? If you think about it, you might have heard yourself singing in the shower. You might have heard yourself singing in your study room. You might have heard yourself singing on the road. Is there a difference to how you hear yourself in all of this? Or you might have heard other people singing. You can hear me speaking right now, and this is sort of a small studio room that we have. I will do a small experiment where I will try to put myself in a different auditorium of sorts, and I will play with the sound effects just so that you and I can intuitively get an understanding of that. What is the difference between what happens indoors and what happens outdoors? Is there a difference? I will tell you, if you haven't already experienced it, yes, there is a difference. It's because sound gets to travel different distances before reaching our ears again. Let's assume that I was standing away from a wall which is 3 meters away. It travels 3 meters, comes back 3 meters. So a total distance of 6 meters before I hear the reflected sound from the wall, right? And if I'm doing this in the open during my cliff and mountain experience, I have many, many meters for it to reach back into my ears. So think about this. Ah, ah. Okay. Or you can hear them distinctly. You can hear them closer together. Can you tell me how many fingers I used just now? Well, I'm using these 4 fingers, all right? You can't really tell that, right? Because the sounds are kind of overlapping. Just like persistence of vision, we have something called persistence of sound. Now, what is this persistence of vision? It seems as though after a particular time that you have seen something and see something else, that vision kind of retains in your mind. Sound also happens in a very similar way. In fact, most sounds persist for 1/10 of a second. What is 1/10 of a second? 0.1 seconds. That means if there are 2 sounds that are generated within a span of 0.1 seconds, it's very hard for us to differentiate that there are 2 distinct pieces of sound. Of course, with training and with nuance, you can always change the persistence range. What happens on the outdoors? I'm just calling it OD and ID. Outdoors, it so happens that sound goes such a long distance and comes back. The time that it clocks is basically a lot more than 0.1 seconds. Indoors, in most places, the time that it clocks happens to be much less than 0.1 seconds, which is why we can experience sounds differently, but it does not feel to us as an echo. It does not feel to us as a distinct sound. Now, okay, here, wait a minute. How fast does sound travel in the air? Well, if you remember the speed, it is 340 meters per second. Well, approximately, right? If speed is 340 meters per second, and I need a time difference of 0.1 seconds, what should be the smallest distance away of the reflecting object such that I hear an echo? Well, the smallest distance away can be calculated as D is equal to V times T. Is it V times T? Yes, it is V times T. But distance from me to the object and object to me. If the object is at a distance away of D, what is the total distance traveled by sound? It's 2D is equal to V times T. Because this time period or this time taken is for the sound to leave me, hit the object and come back to me. So that's a distance of 2D. 2D is nothing but 340 meters per second. Always write the units times 0.1 seconds. 2D. So if I take only D, this D goes, 2 goes down here. So this becomes 170. This becomes 0.1. So that is D is equal to 17. Wait, seconds and seconds cancel out. 17 meters. You see, 17 meters is the minimum distance for me to experience an echo. Now, does it make sense? Inside closed rooms, you're generally not 17 meters away.